Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be focusing on a required practical for GCSE biology. This is a practical that will link to the food test practical in some way. So if you haven't checked that video out, I'll link it for you in the cards or even at the end of this video as well. Thank you so much for your support on all my videos, and if you've already subscribed, I am so grateful that you're here. So thank you very much. Thank you for joining our community on YouTube. You can also find more from me on my Instagram and TikTok at the GCSE science teacher as well. Let's get into it. So, the practical is determining or investigating the effect of pH on amylase activity. It's really useful to know that amylase is an enzyme and the substrate that it is breaking down is starch. Starch can be broken down by amylase into a smaller unit called glucose. And we can actually calculate the rate of amylase activity and determine which pH it works best at in this practical. So it's a very fun practical, very interesting one as well. The variables we need to consider are the control variables, so anything that could affect the result. So temperature obviously can affect how well amylase works. So we want to maintain the same temperature throughout the experiment. And we do this to have comparable results. Remember, controls are used in that way. We also have an independent variable, something that we are changing. And in this case, we are changing the different pHs to determine which one works best for amylase. And then we have the dependent variable, so something that we are measuring. And in this case, we're measuring how quickly or the time it takes for amylase to work and break down starch. And the faster it works, obviously, the better that pH is for amylase activity. And from that, we can calculate the rate at which amylase works at. So let's go into what sorts of equipment we will need. So we'll need some sort of water bath. You can make your own with a beaker and a thermometer to maintain that temperature, or you can use an electronic water bath as well. We'll need a measuring cylinder to measure out the various amounts of liquid or volumes of solution. However, you could also use a syringe to do this, which I actually personally would recommend having a syringe so that you have more of an accurate result. And it's also better than pouring out different solutions into a measuring cylinder because we'll only need small amounts. You'll need at least one white spotting tile. I would recommend at least two. Because that's where we're going to be placing our solutions in, and we may need more than one depending on how slow the reaction is or how slow the breakdown of starch is. We need some test tubes and a rack. We need a glass rod for stirring, and we of course need a stopwatch to measure the time. We also need the various solutions. So you're going to need your amylase, which is the enzyme, the starch, which is the substrate, the buffers that you'll use. So you could have a range of buffers. I went for pH 3, 5, and 7, but you can use different ones, and you'll need some iodine, which determines the color change and whether the reaction has started or stopped as well. So, from experience, when I teach this practical, a lot of students find it quite tricky because they don't know what they're looking for, and there's a few things you must do. So, just to clarify, what you're looking for is a color change. When amylase breaks down starch into glucose, you should be able to determine that based on a color change you see. So, if starch is present, iodine will turn blue or black. But as the amylase starts to break down that starch, there is no more of that starch present, and iodine will no longer go blue or black. It will actually go or remain a brown orange color. Now, if you see a brown orange color sustained for a few seconds, you'll actually notice that that is the end of the practical for that particular pH for that particular round. That's what you're looking for. And I'll show you some examples of results in a moment. But one thing you also want to make sure you do is when you add your amylase and starch, you must start the practical straight away because that means the reaction is already beginning, because the amylase will automatically start breaking down the starch. It's just what it does. So you've got to start the practical straight away. The other thing you want to make sure you do is label everything in this practical. Something you do in other practicals as well, I understand, but for this one specifically, you must, so that you know what each of the spotting tiles means in terms of the amount of time. You can use like a whiteboard pen or like a marker pen to write down the number of seconds on each of the wells if you want to. That is a good way to determine how quickly the amylase has worked. So essentially, you want to label each well of the spotting tile. You may need more than one spotting tile. You want to add a drop of iodine into each of the wells to help you determine if the starch has been broken down. You then want to add the same volume of the buffer solution into a labeled test tube. And like I said, you're going to be using a range of solutions, possibly 3 or 4 different types of buffers or different levels of pH. I've gone for a neutral and I've also gone for some acidic pHs, but in this case, I didn't do alkali ones. You could always do that as well. It's up to you and your teachers. You want to make sure that the amylase, the starch, and the buffer solutions that you're using are all at the same temperature, 25 degrees, something like that. Nothing too high, because if you increase the temperature too much, the amylase will actually denature. Remember, it's a protein, it's an enzyme. So you don't want it to be too high, and that could be one of the reasons a practical might not work. So just consider that in your evaluation. So once the solutions are all acclimatized at the same temperature, you want to add them into the same test tube, and you want to make sure they're all at the same volume. So you've not got too much amylase and not enough starch, that kind of thing. Okay. Once that happens, you've added the starch, the amylase, and the buffer. You want to start the timer immediately, and you want to transfer 1 drop into the first well at time 0 seconds. Okay. At every 30 seconds, you're going to place another drop of that mixture into each of the wells, and you're going to see what happens in terms of the color change. Now, you can mix those wells if you want to with the glass rod. That would be a good idea, but make sure you do it to all of them. And you may want to wipe that glass rod every time so you don't transfer any solution into another well. As soon as you see a color change from blue black, and then you see an orangey brown color, the orangey brown color tells you that there is no more starch present. And that's when you know the reaction has finished. And that's when you want to stop the timer and record your results, and then repeat the same thing again with the same pH. And then obviously repeat the same thing again with the different pHs. And then you'll get your results, which I'm going to show you now. Okay, so here are 3 made up results that I have in front of you. You can see you've got the white spotting tile at pH 3, the white spotting tile with pH 5, and pH 7 on the other side. And you can see we've got a range of different results, and this is what they mean. So pH 3, the reaction stopped at 540 seconds. However, in pH 5, the reaction stopped at 360 seconds, and at pH 7, the reaction stopped at 120 seconds. So just by looking at this off the bat, without doing any fancy calculations, we can see that pH 7 was the best for this particular version of amylase. Now, these results may not be accurate. I have just made these up for the sake of demonstration, so please don't take them as gospel. But I will say, one thing you could identify is the color changes are quite easy to see, and in this case, it's not always easy to see, which is why we have to do repeats. We obviously want to collaborate in our class and look at different results of other people. And also, we want to use some maths. We want to quantify our results as well. So I have worked out the amylase activity, and all I've done is do 1 divided by the time it takes for the iodine solution to remain brown. So in this case, I've worked this out for each of the different pH solutions. And you can see that quantifying this, we can see that the rate is much quicker for pH 7 in these results. If you have done this practical before, let me know what results you got. Did your amylase work at different pH? Did you investigate an alkali solution? I'd be really interested to know. Let me know down in the comments below. So, this is the last part of the practical, which I would actually recommend everyone does, especially if you're going into or looking to go into A-level sciences. And it's the evaluation part. It's the bit at the end of a practical that tells you what went well, what the results mean, and what you could do to improve it for next time. And this is a really fundamental skill, because anytime scientists in the real world do any sort of practicals or anything that could actually benefit society, you have to write up a discussion piece, like a thesis, and write out your results, but also explain your results and how they fit into the current literature of what we understand in science. So this is actually a fundamental skill that actually happens in real life. So in terms of this practical, I've thought about the temperature. Was the temperature too high? Did amylase actually work at all? Um, did we maintain the temperature throughout the experiment? Did we place that test tube back into the water bath to ensure that the temperature was maintained throughout? Because that could have affected the result. Um, did we do enough repeats and calculate the mean average? Did we use a wide variety of buffers? Did we just stick to a couple? We could have used all different types of pHs. I certainly didn't use any alkalis in this example. Was the pace of the practical one of the reasons for the problems we experienced in the practical potentially? So, could we have done, instead of every 30 seconds, could we have done every minute? But then also think about what are the implications of that? And was that enough intervals as well to get the right results? So, lots of different things we could consider and we could tweak in the next round of doing this practical if we did have time to do it. These are sorts of things you want to think about, and you could get asked in the exam as well. Thank you so much for watching. If you have enjoyed the video, please feel free to like the video, comment below if you've done this practical yourself, how did it go, and subscribe if you haven't already. Thank you so much if you are already part of our community here on YouTube. Like I said, you can find me on Instagram and TikTok, where I post lots of videos and support for GCSE sciences, not just biology, but physics and chemistry as well. Yeah, thank you so much for your time. I've been the GCSE science teacher and you have been curious, and I will catch you in the next one. Take care. Bye.